Hey, my name is Abbas Mukhtarzadeh. I'm a NASA Solar System Ambassador and also ASAP Ambassador, mainly volunteer to do the public outreach for the astronomical and science and Earth-related items. And also recently I accepted responsibility as a AIU National Outreach Coordinator. And this is a very brief introduction of myself. Astronomy was my hobby in last, I will say, 40 years or more, and I was had used any opportunity to learn more and engage more on this activity with myself and anybody that I found interested to broadcast the beauty of the starry sky and all the objects and the things that you can easily discover without any problem. And uh, uh, in the beginning, normally you think that is very difficult or science, and sometimes you hear on the word of the mouth that this is a rocket science or things like that. But I normally think it very lightly. This, as I think that kind of when you know and study more, you learn that that is not so difficult and easy to catch. And therefore, this session that I'm providing is supported by NSF, National Science Foundation budget that I have about 250K approved by NSF, and hopefully it doesn't affect the new administration for the approval for the continuation. But the due date for the current project approval for free sessions for public and broadcasting astronomy for public outreach gonna be end in summer this year, 2025. Therefore, this is one of the opportunities that all of us has to learn more on this topic, and because of that, I just make some effort to this happen. And also, I'm thankful for John Taylor that helped me out on this as well as a collaborator. And one of the things that I promote most, not everything can be done by individual, but collaboration effort is going to be very helpful. And also, on the other hand, not only collaboration on the uh, this session, but also I'm gonna go over later on the discussion more detail. I don't want to spend too much on the introduction, but this is a key item for the teamwork and any kind of science activity that we do, and it is important to transfer it to everyone. And I hope, and I know that many of you may aware about this and get advantage of it, and hopefully we get some good out of it from this class. Okay, uh, I give it back to John. I can introduce, and if anybody else wants to introduce, just feel free after John. We can have some uh, know each other and get some collaboration and effort and the learning tools on the class.
That was good news. You're talking like I'm talking. It's met a boss last spring, summer, and probably the best thing that's happened the last year. Been kind of fun to have an opportunity like that. I think one thing to realize with this course is we're just looking forward to having a lot of fun together. I've been wanted to do a lot of these things we're going to do this spring for years, and my background is I'm a physics teacher. Been doing it for over 30 years, been education, and been really working a lot in different astronomy efforts. Got involved with the thing with Caltech back about almost a little less than 10 years ago, and really had the bug before that, but I didn't know how to do certain things. And worked with Louisa, Dr. Riebel, and learned how to do things I didn't. I knew they were out there, just didn't know how to do them. And I think, as the boss said, a lot of this stuff isn't so much as difficult as the rocket science, but it is. But you can do it. It's actually very doable. And so going through this, I'm gonna be. I have my notebooks. I have a notebook I went and got so that I can just keep track of this. I think a lot of this stuff we're gonna be doing this semester isn't just something I would be doing for a one and done. I'm looking forward to doing this for years. Once we know how to access this, and you have some credits to actually find things, I'm looking to milk this as long as I can. And so I see this very much as a collaboration as much as a course, is I think that we'll learn a lot from each other. So I'm looking forward to getting to know everybody in the group. There's about 20 of us. I think that's enough people. We can definitely get to know each other. And I encourage each of you to feel comfortable to approach either of us or anybody in the group if you have questions. Share secrets on what you're doing and how what's working and what's not working also, so we can really gain some traction from this. Going in this first day, I think we're probably as anxious as you are and hoping this all goes right. But I'm very confident. I think this will go very well. I think after the first couple of weeks, you're going to find, yeah, yeah, this isn't so bad. This is actually a lot of fun. And as the each week goes on, you'll be like, wow, I can actually do this. So we have planned a lot of observations as you'll go through the videos that Dan has prepared for us. You'll see that. Yeah, we're gonna use a lot of stuff to do stuff. We're gonna use a lot of images. We're gonna take a lot of data, learn how to do what the professionals do, because you will be using what the professionals use. That's what's amazing. And both of us, if you ever want to talk outside, we have other tools we've learned to use that NASA makes available for anybody to use. They just don't tell anybody where it is or how to do it. And so, as your interest is out there and you want to find things, just know there's a lot of opportunities, a lot of really cool opportunities to do some really fun astronomy. And it's good to be a nerd sometimes. It's good to have some fun with science, and it's yeah, the astronomy, this stuff is just amazing. I think you'll be amazed. I'm amazed with what we did. I'm looking forward to this term with all of you.
Thank you, John. I'm just asking an individual by name. Hopefully I pronounce it good. If I made a mistake, just correct me if whenever it happen. Next, uh, Breakin. Is that correct? Breakin.
Yes, that is correct.
Can you introduce yourself, please? Just as much as you can to know you and what's your interest on this subject. Thank you.
Sure. I am Brecken Green. I am a sophomore in high school. Um, I was told about this program by my chemistry teacher, Miss Cooper. Me and another student from the high school are in this class. Um, I was born in Louisiana, of all places, and our family moved back and forth from Louisiana to Colorado about 2 or 3 times. And my dad went to nursing school at some point, and we found a job in Montana. So we moved from the south to the far, far north. And we stayed in Montana for about 7 years. And then after about 7 years there, we decided that maybe we wanted a little bit more land because it's a little bit cheaper down here. So we sold some of our land up there and moved down here. And so we've only been here about a month or two. So
Thank
Nice.
you for great. Hopefully, you get some good from this session and program. And thank you for joining us. Next one, I see Kripa.
Hi, I'm a junior at Marvin Ridge High School, and I joined this program because I'm part of the astronomy club at my school, and like the physics class, and Mr. Taylor is actually my teacher, and he recommended OPIS to my class and like the astronomy club, and I've always had an interest in like astronomy and like just all that kind of stuff. I've always found it really wonderful. And I I've never really had like a formal education in astronomy. And so I wanted to kind of get that sort of experience. And I think it would be really great to be able to observe things. So
Thank you. Next, Roy. Is that pronounced it good?
Rui. Yeah, my name is Rui.
Rui. Okay, sorry. Thank you.
Sorry. So my name is Rui Yin. I also go to Marvin Ridge High School, and Mr. Taylor is also my teacher. I am also in the astronomy club, and I help run the physics club as well. One of the main things as to why I really like this program so much is because it aims to make science more accessible to everyone, which is what I try to do with the physics club. I try to make it like less daunting for people to learn because like, oh, it's physics. It's so hard, right? It's like rocket science. But I try to make it kind of simple as simple as I can. Um, so that's why I really like this program so much. And I've also been into astronomy for like a while. That's what got me into physics in general. So yeah.
Thank you. And the next, Pranav, is that pronounced that
Hi,
good?
my name is Pranav, and I'm also in Mr. Taylor's class. When he told us about this, I thought it could be interesting. I've only recently got into astronomy, and I thought this would just be like an interesting thing that I could do, have the opportunity to do.
Thank you. And next, Noah.
Hello. My name's actually Justin. For some reason it's a different name, but I'll have to fix that later. Um,
Thank you.
yeah, sorry. I go to North Green High School with Brecken, and Miss Cooper also told me about this, and I just thought it was really interesting.
Thank you.
Yeah,
Sh is that done? You want to add
yeah.
something on it?
No, that's all.
Thank you. Sharias,
I'm in Mr. Taylor's astronomy club. I'm also in the physics club from Marvin Ridge, and I'm a freshman. And I just thought this would be like an interesting program to like learn more about astronomy.
thank you. And Farhad,
Hello, everyone. I'm Farhad Samadi from Toronto, Canada, and I've been a lifetime student. By trade, I'm a petroleum engineer, exploration and production. So I've done quite a lot exploration below the surface of the Earth and under deep in there. Now it's time to explore more about the skies, which is kind of infinite. So that's an honor to be part of the team, especially the younger ones, the students, and the teacher, John Taylor, to learn more about science and technology. And my interest to the astronomy has been actually part of my job because I used to be in offshore and onshore desert places, and then looking at the sky at night. It was so beautiful. Now I just enjoyed it, but now I'm going to be more enjoying by learning about it, that what is it made of, and how we can I had a model of the universe before, but now I believe that through this training I will have a more realistic model of the universe, and very proud of being part of this. And Abbas is a good friend of mine, personally and technically. We work together at some point, so we have some conversation about the subject, and that's what brings me into the team. Sorry for going into a little bit more details, but I'm glad that I'm going to learn from the younger ones. So that's a good thing. Thank you.
thank you, Farhad, for introduction and everyone on the team. Uh, do you want to add something on it, John, before going to the what do you call it, more detail on the main topics of the orientation?
I
John?
just put in the chat, just kind of cool. We have, so North Green is in Tennessee. Is that correct? You guys are at, all right? And we've got Marvin Ridge, which is in North Carolina, and we have Toronto, a beautiful city up in Ontario, Canada. Love Toronto too. So it's kind of nice. We have people spaced out over here kind of connecting, and we can do that with this.
And I believe all of us we are on the Eastern Standard Time. I'm not sure about the Tennessee, but Tennessee gonna be EST also as well, right? There's
Do you guys,
a Eastern Time, Tennessee, I believe.
do you
We
guys
have
do
the set.
savings or not? Daylight savings or no daylight savings for Tennessee? Do you change your
I hope,
clock?
yeah. But I will check it later on. Don't worry about this. But we will go over there. Then, if you want to add something before the start of the web, I'm gonna go over the two websites that we have, and also introduce the Dan Reinhardt, professor of the UNCC, that is developed since last 20 years this program, and then that's the kind of orientation that I taught on this session of today. Do you want to add something on it, John, or I can start?
No, it sounds great. Let's go ahead and dive into it
Sure,
and get through the nuts
sure.
and bolts so we can get on to the fun
Uh,
stuff.
Let me share the screen.
Oh, hey, a couple of notes as we're doing this. One thing which I did, I just go to Walmart or someplace like that. I got myself just a nice little notebook for notes on this. I like doing that. I know a lot of you're younger, we older people, we kind of lose things. But if you can remember it very well yourself, but I like to have a little handbook, and I'm just taking notes as I go through because a lot of this, like I said, as we go, it'll be very repetitive, and from repetition, you'll remember it. But I'm afraid, like a year from now, I want to look up M15. I want to take an image of it. I'm like, oh, how do I do that? So I'll probably be making myself a little reference book as we go through these activities to remind myself how to do it. You may be surprised in college someday if you take like Dr. Reinhardt's class at Chapel Hill or someplace else. They'd be like, oh, we did that before, and a little refresher like that. But I do see this very practical. I like observing things. I like, accessing telescopes around the world and pulling off images. I think it's really cool. So just a suggestion, if you have some place to write things down and keep a little notebook that's dedicated to this, that'll probably make everything work really well. As far as completing the exercise and all that, you'll have a nice reference.
Thank you, John. Let me see. Screen. Yeah, this this actually this one. Let me go over the website that we had. Normally, for the first one, web assign, you just click web assign, and you see two website comes. One, this one that with the red icon. The other one is Cengage. This is the one actually we needed to go over. And then this one, let me see where it happened. Okay,
Yeah. Abbas,
I I
are you sharing your screen?
I am just try to share. Yeah,
Oh, I see. Okay.
yeah. Right now you see it. Is that correct?
Yes, I do. Yeah.
Okay, thank you. Then, as I mentioned, when you do the uh, search for the web assign, two websites comes with the same name. But the one that is important for us is the second one is blue uh, items Cengage. When you click it, and then I have my account here. I already created, but you have to click here and then sign in and sign out. And based on the instruction that I give it to you, I hope every one of you have access to it and created the account accordingly and look through it. And then let me go over again to make sure that we have. When you go to the dashboard on this website, on the dashboard on the left side, you see my library or my courses. And when you click the my courses, you will see it, uh, this class, they call it ASTR 100L. ASTL 100L is mainly the basic astronomy. I'm gonna go over on this case later on. And you see here different labs for current assignment that he had. Lab 1, 2. Lab 2 is 2 session, 2S and 2G. And we have lab 4, and the lab 5, 6, 7, 8, and 9. This first one is that we're gonna start from Tuesday. Basically, that's the main orientation of the technical aspect of the remote observation and basics of the astronomy. And then on the second one, we're gonna go to the Earth and season. That is basic for our understanding of the Earth as one of this sky object, although we are sitting on it and we're watching out. And then the labs 4 to 9, it's gonna create a kind of curriculum for the astronomy based on the distance ladder. This distance ladder is basically start from the or location on the Earth and goes to the planet and the solar system, and then beyond that. Therefore, we're just creating to understand the sense. Most of the time, we know that distances on the astronomy measured by the light years. And to understand clearly what that light years is, this curriculum is provided to understand, to start from ourselves on the Earth and go to the whole universe. And based on the Hubble law and Hubble constant and the last two sessions, we get some feeling of understanding how the distances are worked and how we can easily measure them with simple tools on this class. Let me go over for one of them introduction and here. Each typical session that you're gonna have, you're gonna see five typical or 4 or 5. One is the introduction, one instruction, background, and also procedure. That in here we have two procedure because um this lab 1 introduction to Skynet is main things that we need to learn. And when we learn, we're going to use it more often on the next labs. And each section, when you click it, you will see nothing except two videos. One is original, one is enhanced. The original is the original recorded session that is provided by a company named Glass Education. Enhanced, the one difference with the origin is that, for example, on Enhanced, they added some arrows, they added some more sharp tune kind of orientation and zooming and things like that. Therefore, if you want to have a better, I think Enhanced provided a more educational video from original, but you can look through any of them. But my recommendation is that you use Enhanced for each case. But if we go again to the next one, instruction, also we have a video. Most of the videos is 5 minutes or 10 minutes or so that you can easily access to those. But the next one, background, that is also same thing. We have a video presentation for the background. And then let me see again, and procedure. Every one of them is a kind of instruction by the video, but description is given inside under these links, 5 video links on the first lab. And one of the important is that I share it with you, observation guide on the last email that I sent it you. It gives you some in the Word format how you can organize the labs and investigation or each plan and planner that we have, tentative preliminary plan that we have. But several items that is important here. Uh, you can for each question, you can submit, for example, if you want to take a picture and measurement, things like that, you can submit many submissions, but most of the time, it will save the only last one. Sometimes you forgot to submit the button and you save it because you are not sure the quality of the picture or things like that. Therefore, if you don't submit it, it doesn't save you. And therefore, I recommend you whenever you have a chance after you uploaded the data on the place that I'm going to show you, you submit it as needed. And also, WebAssign doesn't do that for you. You have to do it yourself. And every calculated value, we consider three significant digits. And one of the key items that we need to take it out, for example, in the for the scientific notation like this, uh, is a better. We don't want to put it like this. We have to make sure that address it correctly. And you don't need it to add any units for numerical responses. And because every WebAssign program doesn't accept that. This is the basic things that you can go over and review it again, and also uh, learn gradually on the session. And when we go to the introduction, it's kind of this is first goal of the lab one that we have to observe and adjust the brightness and contrast level and measure the angular size of the object of the image and identify the object. And this we're gonna go over on detail on here. And next one, equipment. The only equipment you need your computer with internet connection. No other equipment you need it. You're gonna connect with remote telescopes on the world. And this telescope that you see it as provided by Dan Reichart and the students that is kind of, they call it panchromatic robotic optical monitoring and polarimetry telescopes. The abbreviation is PROMPT. It created in 2004, almost more than 20 years ago, in Cerro Tololo in Chile, CTIO. And therefore, as you see it on this picture, they have very dark sky and a remote area, and one of the best places that you can enjoy the kind of beauty of the sky and Milky Way and different places. And here it shows you some typical telescopes. Say this is the one from telescope in Australia, and that's each of them you can engage and use it. And here there is a kind of background from telescope that we have that this is a kind of initiation of this program started from this one. At that time, uh, Professor Reichard and the student, one of his students, working about the gamma ray bursts. We're gonna learn later on about these items. This is a kind of death cries of the massive stars and birth cities of the black holes. When they started that one, they learned that how to use that remote telescopes, and then uh, while they not observing this research project, they said, why we cannot use the remaining 90% of the time for other research across the state or country or around the world. The students from all ages graduate through the elementary school. Therefore, they said, we don't do 100% use for this project. Why we cannot use for global knowledge and also learning tool for everybody and help to items on the astronomies. And these things become very serious, not only on this project, but right now, as you know, on the news, we're receiving many more data on the uh, recent telescopes, either on the Earth or in space, but we don't have enough professional astronomers. And professional astronomer, I mean the individual that do the astronomy, but they get paid and they work, main work is astronomy, like professors and researchers in astronomical center observatories or institution of NASA, ESA, and CSA. But the thing is that the data is huge, and that data is not able to everybody. All the professional astronomers might be around several thousand around the world. They cannot handle investigation of those. Therefore, concept of the citizen science comes that everybody can go and study very simple things and help do the scientific things, actual or published articles like a scientist. This is a a picture of the Professor Reichard beside one of the prompt telescopes, as you see it. And this is one of the telescopes that you see it. As you notice, several items involved on here. This is when the light comes from the sky, from a star, it's going to be reflected on the primary mirror at the bottom, and then reflected to the secondary mirror on here, and then go back to the back of the uh, digital camera or filter that exists at the back of the telescope. And there is a here mounts exist that create a motor for operation of the telescope. As many of you has a telescope, you know that how it works. And the filters that they have normally, it has different brand and colors that we're gonna go over the class on that. The main things on the color is that when you have a, for example, this is the color of the uh, parrot on the right side. As you see it, this is colorful, but this color comes from a spectrum of the light. For example, on the red, you see it like this. On the green, you see it like that. And on blue, you see it like this. And when you're combining all together, you see it this color. But actually, when you take a picture, you may see it black and white like this. But uh, on the activity that in astrophotography we do, we just transfer this black and white to the color and combine them to get the natural color of the picture as needed on most of the camera that we're using. We're gonna go in more detail on this, but this is a very high level review of the activity that we might involve on that. The prompt is very complicated system, and it may fail, it may not work sometimes. It doesn't mean that when you take a picture for your work in the lab, you're gonna work it out or no. And some failure, we have to notice that on the picture that we're gonna show later on here. But this section, I don't want to go too much detail on here. You can go over whenever you have a chance to get to know it. This is a very interesting topic here. You can look through it. For example, in here, you see this color and this color has something is wrong. They took a picture, but there is some clouds or blocking or something happened on atmosphere, and you will have to retake it the exam. Here also you see it on the left and versus right. You see some dots here is uh, blocking cloud that created the picture not good. Here also you see distorting the star are moving. That is picture is not good. You have to take it again. And here you see it the picture taking, but the object is off the center, and you cannot see it. What is the on the left side of the picture here? Therefore, this is a strike of the tracking problem on the mount, and here some focus misbehavior, and here just shutter uh, not working properly on the camera, and here is the light. Someone uh, is a kind of light at the telescope. Proximity of the moon is create a problem. Here you see it. There is a satellite moving or airplane. And then there is a bug here. That's one of the fun things that you may see it fun because there is nothing there prevent the bug to come to the telescope. And then you have to retake it again. But anyway, in the remaining of the labs, I don't want to go too much detail on that. We're going to observe the moons, dwarf planets, deepest sky object, and the selected region of the moons and beyond the lab. We're going to go over. I don't want to spend too much on time here, but I want to emphasize one last item here that the picture that you see it on the social media is like this. These pictures, you don't expect that you're going to get these pictures either by your telescopes or your this program here. The things that you can see it like this, and this is very good also. Why? You can see it the color path, color white cap of the pole. Here you see the light features on the moon surface here and here, and you see the dark regions as well here. Although it's not precise like this, but it will give you some indication. For example, it indicates exactly what the size of the Mars is from left to right or up to down, and you can get the similar shape on that. Therefore, the pictures that you see it in here, the submittal that is provided by previous students, an example, and you can choose yours and insert here after you get the Skynet. And when you do that, you provide a Skynet observation and record it. And then you provide some note here. That is very important to put some notes here to give indication what you feel when you do this activity and what you learn. And that's kind of things normally is we using. And also there is some notes here. You have to watch out when you just give you some indication what the possible responses you can put here. That also help not only you, but everybody on the team to see how we can learn from these activities. And so far, I just go over this item and I want to stop by and then give any question you may have, you may ask or let us know. Or John, if you have any other items on this, let me know. But next item after with short question and answer, I'm going to show you the main scope of the curriculum done on the website that Dan Reinhardt created on his own website. I'm open for a question. Go ahead.
Yeah, so a couple of things I want to point out here is when using your credits, you have credits to do observations. Be very conservative with that and be kind of careful as you go through. Like he'll go through the instructions. I just want to make sure you don't miss this one. It'll tell you like how many credits an observation will take. And when I first was introduced to this, that idea wasn't shared. And I remember using almost half my credits in the first day. And I'm like, oh no. A lot of these observations can take 1, 2, or 3 credits, but there's some that can take like over 1,000 credits. So be kind of careful on keeping your balance and watching how many you use so that doesn't go too fast. Another thing, as we get into this, you'll learn take the images really, really early. Don't wait. You can't really wait till last minute because it takes time for these telescopes to do their things. They're all robotics. It's automated. They have all types of sensors that'll shut them down or turn them on based on what's going on. And it's very likely that your images will be maybe okay sometimes, and then sometimes it'll be fantastic. And so it's good to do it early and get a fantastic and be great. But then when they're not, you're like, oh, I got to take another one. And so to make sure you get those shots done, just realize that's going to happen. I did check, and I think most of these telescopes we're looking at are such high altitude that a lot of things we worry about, like rain and snow like that, I think they're going to be above the clouds. And so that's not as likelihood. Lower altitude telescopes they shut her down. If it's rain's coming, snow's coming, they shut her down. I think some of these we're using are pretty high altitude and we can avoid that problem. But all the same, it's good to do it early and not do late. I know all the same, I will be checking, like we're going to learn tricks and things to use. Like I'm going to go to clear dark sky for that region and kind of look like what is the weather like in that area possibly, see if it affects the observations. It's as a site that shows you kind of cloud cover and smoke, winds, rain, are there forest fires nearby, that things like that might cause a problem. It won't detect bugs, but it will do a lot of the other stuff. So just we're going to learn as we go, but I would say take your images early and really watch your credits as you go through them. Any other questions?
Thank you, John. Any question?
Yeah, boss, one question we did have was, and we'll have to come back to this before we leave today,
Me?
is there was a question about the class code.
Okay,
And
yeah. The class code, there is 2 class codes. One is the web assign that I sent it on the email originally. I will resend it again. Let me check. I will check the email and send it again. That the class code. But when you adding that class code, you can what to call it? When you register to WebAssign, they're asking you the class code. You enter that class code and the user ID, and then that's gonna be set up easily. Sometimes it's not easy, but You have to work it out, and hopefully that is happen. But when you try to that one in the next few days, if you cannot succeed, just send me or John email. We will see what we can do, or we can have just a direct. I will ask a direct Zoom meeting with each other and go over that. John, go ahead.
The other, as we go into the pre-survey, it asked for a code. I think we just make up a code for that one.
Yeah. There was another thing on the survey. The survey, I don't know how many of you you finished it up the survey or no. We have two survey, and those survey is not gonna be recorded by your name or your identity, but it's gonna ask some student ID. You can assign any student ID yourself. We don't assign for you, and you keep it in some way because the reason is that we have two survey at the beginning, two survey at the end. Uh, Please use the same student ID because they're gonna compare on the program. Because I told you this program is funded by NSF, National Science Foundation, and this survey is gonna help to promote this and get value because they're gonna submit this one back to the NSF this year, next year. Hopefully, they extend the project for another year or so. Therefore, if you participate in the survey, it's going to be very helpful to make it sound how this is improved. For example, I didn't know before when I engage in this session, I learn a lot and know better. That kind of things provide more uh, kind of learning tool for NSR funders that know that this program works and get promote the science among the public.
Okay. So going back on the Cengage, most of us, I think when you come in as a student, it says you have like 9 days left. And when you go into to join the course, it asks for a different, it says enter access code. So that's, I think that's the code everybody needs, is what is that code that takes us from temporary access to permanent
Yeah,
access?
that's another one is we have two things. One is student ID that is up to you. You don't need it to worry. You assign yourself something, both on the beginning and end. You keep it the student ID, whatever it is, keep yourself. Another one, class code that start with UNC that I sent it on the first email, I believe. That one I'm gonna resend it again. Those, when you introduce that one, it gives you temporary access. But later on, probably that they're gonna send it to you in the what to call it, the uh, by email, a key, class key. That's three different things. Your student ID, as I mentioned, class key start with UNC, and our website key or registration key is different that they're gonna send it by email. I'm gonna double check with Dana on this and also to see if there is a glitch. Sometimes they send it on a spam and sometimes somewhere else. And uh, I hope it's gonna receive in near future, but I'm just believe it's gonna take um, a few days or might be a week or so long. It may sometime takes, but I will ask them to make it more quicker. But one question, the one that you have access web assign, because I can now see it on the website that we had consider on the what you call it, web assign on the case that I registered. I see many of you on the name on the course exist. For example, let me go over again. I double checking my screen. I see majority of them you have what to call your name is here. I see Rio, uh, Roy, Kipra, Farhad, Pranav, Justin, and Sharias. I added you, and also I see that you log in this morning. But one question, let me share you this uh, item again here in the screen. As you see at the screen, I have all of your list here that exist. But one question is that when although you registered, your name is here. When you go and, for example, I go back here on the course, can you see the this what you call it, labs, and you can click on view and see the things or no? One question I have from everybody that registered. Do you see this? Can you access to this page on the web assign or no?
I can access them.
You can access?
Yep.
Okay, good. And when you click it, probably try to see if you can see one of the videos. If you can click it here, you can see the video. I will do one of them. Let me stop sharing again. Share with the what to call it, audio. Share sound. Okay, share. I will share it with you, this video, and then hopefully you can hear the voice.
All right, welcome to lab 1 of our sequence called Our Place in Space, which makes use of the Skynet Robotic Telescope Network. Most of our labs will make use of the Skynet telescopes, though a few will be traditional in that you'll collect your data via other means. Now, lab 1 will take place in 2 parts, which at most institutions will be spread out across 2 separate weeks. In that first week, you'll learn how to use Skynet, which is our image acquisition system, and you'll use Skynet to observe a great many things, mostly solar system objects, planets, moons, dwarf planets, but also a few deep sky objects such as nebulae and globular clusters and galaxies. Skynet will then go off and collect these images for you and get them back to you. And then in the second week of Lab 1, you'll learn how to use Afterglow, which is our image analysis system, which we also designed and developed. Using Afterglow, you'll view your images, you'll learn how to adjust the brightness and contrast in them to bring out more details. You'll learn a few basic measurement skills, such as how to measure the angular size of objects in your images. And you'll learn how to identify objects in your images. So we're going to have some fun. We're going to image a bunch of stuff. And at the same time, we're going to develop a skill set, a toolkit that we can carry forth into the remaining labs in the sequence and build on in those remaining labs. Now, the remaining labs will be based on what astronomers call the cosmic distance ladder. And Lab 2 will start close in on Earth scales. And as we go through the labs, we'll work ourselves farther and farther out until we're studying the universe in its entirety. Now, in the upcoming videos, I'm going to overview the different parts of these labs. In the next video, I'm going to explain the instructions that you'll find at the beginning of each lab. Then I'll overview the background sections of Lab 1. And then I'll briefly overview the procedure sections of Lab 1, and only briefly because embedded in these procedure sections are other video tutorials showing you how to do the various tasks in much more detail. Okay, that's it for this video. All right.
Hey, that question that I have, is that everyone have access to these videos on this page, Web Assign?
Yep.
Okay, okay, that's good.
We got a lot
That's
of
good.
yes in the
Pardon me?
in the comments. If you could reply that you are able to see, I got most of us are putting in comments that yep.
Okay, that's
yep.
good. I think this is a kind of basic things that remaining. I think that temporary should be go away, but I will ask Dan to see how we can resolve it. That hopefully that is temporary and you get final access to that and no issue. The last thing that I wanna say, we have few minutes left. We may go over the 1 hour, but I will gonna show you very briefly what this curriculum is. That if we go and check Dan. Here, this is his website that is created. And if you click on the education part, this website has very good tools for everything, the things that Dan provided. And also on the outreach, for example, we had many different things and ATSC and other items, but this is kind of curriculum that they had it to use, and the research and the kind of other items you can go over and look through it is free. And this is, let me see if the one that is, I want to show quickly. Yeah, here is the one that is cosmic ladder that Dan Reinhardt provided. We start from Earth, we go to the kind of different measurement scale that we have on astronomy. And these are basically very simple geometry. And you can learn easily on those, hopefully on next sessions and labs. And this is kind of very good picture on the, I don't know, you can see it, my screen. I'm just
You
tried,
need to share your screen.
I think is, let me do it again. Might be, okay. I missed it. Sorry, I have to ask beginning. You see it right now. Okay. Then here it shows the distant ladder technology, OPIS that we're using. We're starting from Earth to go to the larger distance Hubble law on the distance for the galaxies and the universe and things like that. And we're going to use different techniques here. But basically, all of them is like a parallax, stellar parallax, is basically based on the very simple geometry. Hopefully, everyone understand that and catch up quickly. And the one that you see it here is very good in this consideration. This basic facility that we have, Skynet, Prompt, Radio, and Afterglow, these are the telescopes and the program that developed by University of the North Carolina in Chapel Hill by Dan's team. And then next step that we are here, OPIS, is kind of first level on astronomy course learning tools. Is similar to the Astro 101 in the colleges or university or high schools. And then after that, there is many other things that goes to the beyond research and more detailed analysis. And therefore, there is another one, MVU. MVU is multi-wave universe. It is kind of more work on the giving the color. Right now on OPIS, we're gonna provide only black and white pictures. But in MWU, we're gonna add some colors on it. And I'm hoping that if we can have another session after this semester for MWU to learn how to add the colors to the pictures and get more involved on that. But that is pending. I am not sure that we're gonna have that or no, but I try my best to see if I can get hold of Dan and the teams on Skynet and Prompt. We can have another session next semester or so for this one. But this is, I want to show you very kind of very symbolic way how the process works, and hopefully, and this is on the under development. It's not developed yet. It's only developed the curriculum that we have so far is OPIS that gives you basic of the astronomy and also astrophotography together. And hopefully I will get a good result out of it. And you can go over this website. This I will share it with you in this uh, chat. Then you can have it. Let me see. Can have it access to that and copy it and use it as needed and go over it. Any question? Okay. And I hope you can start learning. I think we just put it this introduction on the weekend, especially because most of you might have time today and tomorrow go over. And if you have a question, just let us know. And hopefully we get start a good kickoff from these activities.
So we'll keep running these on Tuesdays and Saturdays. And I went ahead and put together a group me. If anybody wants to join that, I think a primary communication be through email, but I'll throw that out. If anybody wants to chat through that, we can use that also if that's useful.
Very good. Thank you, John, John, for this help. Therefore, if you can, I think you added on the chat, I believe.
Yeah,
right?
and I will. I'll send that out to your emails. You should get
Oh,
something.
email. Okay. If I will share that email for everyone, then we can have that meeting, and then over there, that's a good idea that we can have a close collaboration and question and answer, help each other if we encounter. Sometime your help gonna be help for me as well and John. Therefore, we are working as a team in here. And thanks everyone, and hope everyone has a good output from this program.
Yes. Looking
Any
forward to it.
question? Okay. Glad to everyone see and hope you see again on the next sessions, and have a wonderful weekend.
Bye. Thank you. Have a wonderful weekend.
Thank you.
Have a good weekend all. Thank you.
Good to meet
Thank
you
you
all.
so much. Have a great weekend.
So,
Bye.
Bye. Have a great weekend.
We'll see you.